One more example of integration by parts. This is the 6th example in James Stewart's Calculus 6th edition textbook for the first section of the chapter, which is on integration by parts. And he gives a sign reduction formula. So a reduction formula is a formula where the exponent n is reduced to n minus 1 or n minus 2. So the value of this is it gives us a way of approaching the integration of sine raised to some power n. So I'm constantly in awe of these professional mathematicians, over the years who've come up with these things. At some point, someone said, okay, can we come up with a formula for integrating sine to a power? And what they came up with is, well, let's try integration by parts. Let's go ahead and let u, integral of u dv, let's let u equal 1 power less than this. Then that would make dv sine of x, because when you multiply u dv, multiplying by each other, when you multiply those by each other, you have sine to the n minus 1 times sine to the 1, which is sine to the n minus 1 plus 1. The ones cancel out, and you're just left with sine to the n, right? So when you multiply these two together, you get sine to the n of x. Great, integral of u dv. Okay, we found our basic approach. So what is du then? Well, du, this is something to a power, and when you're taking the derivative of something to a power, the power is multiplied by the front, which is 1, right? Coefficient, and then you take the power down 1, so sine to the n minus 1, and then of course chain rule. You've got to take the derivative of the core thing there. So the derivative of the sine of x is the cosine of x. All right, it's not pretty, but we have found du in this particular case. So what is v? What is the integral of sine of x? Well, then the negative cosine of x, right? And so now we've got all the players on the field. Let's play. So the integral of sine to the n of x dx is going to equal, so the integral of u dv equals uv. So here's u, here's v, minus, and I had to put it on 2 lines, I'm sorry. I didn't have to, but I did, so you could see it, equals the integral of v du. So what is v? There's v. What is du? Well, there it is. Man, that's a monstrosity. Okay, so we're on our way. Let's keep going, see where it leads us. So the sine of this equals this minus this monstrosity. Okay, well, let's clean it up a little bit. So we've got negative cosine of x, sine to the n minus 1 of x. So that's this part here, the uv part. And then the minuses cancel out. Let's go ahead and factor that n minus 1 out of the integral. Whoop. And so we're left with cosine of x times cosine of x. That's cosine squared of x, times the sine of n to the minus 1, n minus 2 dx. Oh, I left an x. There should be a sine of x dx down there. Can you live with it? Probably not. Hold on a second. Let me fix it. Okay, now I feel better. I got the x in there. All right, everybody see how we've done it? Any questions? So we did this. We did the integral of u dv equals uv minus the integral of v du. Simplified it, did a little cleanup, swept the floor, and this is what we ended up with. Okay, now I'm going to lay aside this front bit. I know it's not perfect, but for the sake of pedagogy, I'm going to focus on just this last bit here, okay? Just this last bit here. Here we have it. I've isolated. I've got to remember, I've got to put that other stuff back in. Got to get back to the other stuff. But for simplicity, let me just isolate this virus right here. All right, well, there is a trig formula that we know. We know that the cosine squared x plus the sine squared x equals 1, right? That's basically a version of the Pythagorean theorem. A squared plus b squared equals c squared. But it's the unit circle, so c squared is 1. So if we take sine squared x plus cosine squared x equals 1, and we finagle a little, we've got cosine squared x equals 1 minus sine of x. So we can substitute that back in for this. It's going to be a little messy for a second, but it's going to equal, substitute that in, 1 minus the sine squared of x for that times this bit right here. Okay, so now let's go ahead and multiply it out. So the sine, so this times 1 is sine to the n minus 2 of x, right? That's sine of the n minus 2 of x times 1 is that. Minus this times this. Well, sine squared x times sine to the n minus 2 of x is the sine of 2 plus n minus 2. 2 minus 2, 0. And we're left with sine of n, sine to the n. Okay, so we have simplified this up here to this. When we've got everything in terms of sine now. Okay, now let's go back and put it all together. So it's going to take me 2 lines to do it. So this was our original problem. It's going to equal this. This is what we got from multiplying UV, remember? That's what we ended up. And then I set that aside for simplicity's sake, but I got to bring it back now, the n minus 1. And then I just had these two. So just to save space, I'm going to multiply that n minus 1 times both of these, okay? So n minus 1 times the first one minus n minus 1 times the second one, okay? See what I've done there? This minus this, I've multiplied n minus 1 times each of those, pulling it back in from before. All right, there we have it. Now, what you might notice is, remember the example, if you've been following these videos, I had an example from Stewart where he then took this, because this is the same, and pulled it back to the other side of the equation. So if I add n minus 1 times the integral of sine to the n power of x dx, if I add that to both sides, what I end up with is, on this side, n plus 1 times 1 plus 1 is n, right? This is n minus 1, but we added another one, and so it ended up at n. So I end up with n times the integral of sine to the n of x dx equals this uv expression that we had, plus n minus 1 times the sine to the n minus 2 of x dx, okay? See how I've gotten that? And then all we have to do is, if we divide both sides by n, we end up with this expression, that in general, the integral of sine to the power n of x dx is going to equal minus 1 over n times cosine of x sine to the n minus 1 of x, plus this divided by n minus 1 over n times the integral of sine to the n minus 2 of x times dx. Okay, now this expression, as horrible as it is, horrible expression, can help you, if you keep plugging away, to solve for the integral of sine to the nth power, the sine of x to the nth power. So this is a reduction formula because we have formulated n in terms of an expression that is n to the n minus 1, sine to the n minus 1, and n minus 2 here. Okay, this is the last example, finally, in this first section, integration by parts.